Okay, 8.5. 8.5, we're going to talk about law of sines and law of cosines. Before we do that, we're going to look at trig ratios for obtuse angles. So these calculators out, and we are going to find what the angle, the sine of 135 degrees is. So this would be an obtuse angle, correct? Greater than 90. What do we get? Correct? 0.707. Okay, so just out of curiosity, can you tell me what sine of 309? No, I'm sorry. 495 degrees is. Same thing. Same thing. Okay. What is the sine of? Let's see. Can I do this in my head? Sine of negative 225. Can you do that? What is that? Error. Yeah, you should have gotten the 0.707. Okay. So any angle that you have, if you add 360 degrees to that, it's the same thing. Any angle you have, if you subtract 360 degrees, it's the same thing. If I add 360 degrees to this, right, it would be, anybody want to hazard a guess what this is? Sine of 855? 0.707. And the reason being is that if on a circle, right, this is the angle that you're looking at. If I go around 360 degrees, I go, oh, I come right back to that same angle, right? If I add more 360 degrees even more, I just go around the same thing, but I end up with the same angle. Does that make sense? Not something you guys have to know yet. I'm just kind of planting the seed here. Okay, everybody got that? We good? All right. Okay. By the way, anybody want to do this for the calculator for me? Same thing. 0.707. Isn't that funny? Okay, so how was that? Let's go to, so I'm going to assume I'm not going to do number 3, B and C. I'm going to go straight to example number 2. Before we do example number 2, we're going to do the law of sines. The law of sines says that angle A, angle B, angle C, and their opposite sides. If you opposite sides are going to be small a, opposite B is going to be small b, it's going to be small c. Then geometry here. Sine A over A is equal to sine B over B is equal to sine C over C. This is the law of sines. Okay, law of sines tells you this is the way this works. Let's go to example number 2 and see if we can figure this out. Example number 2. So on example number 2, first one, I have 32, 105, 18. 32, 105. The length here is 18. And what was the question? The question is to find df, is to find this guy here, x, that length. Okay? So what would I do? This angle, the opposite length is x, correct? So sine 32 over x is going to be equal to sine of 105 over 18. correct? Now we just cross multiply and figure out what x is, right? So I'm going to get x times the sine of 105 is equal to 18 times sine of 32. Divide both sides by sine of 105. Okay. Okay, now when you do this, please remember, okay, there is no shortcut where you can say this is the same as sine of 32 divided by 105. Okay, it doesn't happen. Okay, you have to calculate this separately, and then calculate this guy separately. Okay, all right, and then you multiply it by 18, and if you do that, you're going to get an answer of 9.9. What the book says, 9.9. Okay. So that was example number 2. That was the first one. Let's look at the second one. In the second one, I am given 5,775. 5,7, this is 75 degrees. And they want me to figure out what this angle over here. I want to know what this angle here is. We'll call this x. Okay. So the opposite of this angle is this guy. Opposite of this angle is this guy. I know everything. So sine of x over 5 is equal to sine of 75 over 7. Right? A number, we're good to go, right? So sine of say x is going to be equal to 5 over 7 sine of 75. If I cross multiply, right? If I cross multiply, I get that. Or I'm not cross multiplying, I'm just multiplying the 5 over here is all I'm doing, right? So 7 over 5 over 7 sine of 75. Anybody do this from this side for me? If I do this, what do I get? Book says, my book's not going to tell me. So how the question is, how do I find what x is? I know that sine of something is going to be a known value to me, right? So, but how do I figure out what that x is? Remember we were using the arc sine, the inverse sine, right? The inverse sine, that's what you use, the arc sine, okay? If you use the arc sine, you will find that its x is going to be 44 degrees. Okay. So here's the question. What if I gave you not this, but this guy? How would you find for x? Now I have this guy, I know the opposite over here, right? So sine of x over 5 is going to be equal to this guy over this, but I don't know what this guy is, correct? Or I can go this guy over, sine of this over this side, but I don't know that side. Right? I know that. I do not know this side either. Right? So it seems as though in this situation, I would not be able to use the law of sine, right? To figure out the other lengths or angles or whatever it may be. Correct? Because I know this side, but there's nothing here that I can use. Right? So before that kind of stuff, we would use the law of cosine. Law of cosine says the same triangle, if we had this triangle right here, okay, says that a squared is equal to b squared plus c squared minus 2 BC cosine A. Okay. B squared C squared plus A squared minus 2CA cosine B. C squared is equal to A squared plus B squared minus 2AB cosine C. This here is a law of cosines. And so we'll use those to do what we just, remember that situation where we had the side angle side where we couldn't figure it out using the law of sines? We would use a law of cosines to do that. So on the top of page 571, law of cosines, the law of cosines. Briefly take a gander at that, see if you, it's doing the same thing here, right? So let's go ahead and do example number 3 and see if we can actually use this thing here. Example number 3. Find each measure, and we have 9, 14, 62. 9, 14, 62 degrees. And what do they want us to find here? They want us to find BC. They want us to find this guy here. Okay. So this guy, x squared, is equal to this squared plus this squared. 9 squared plus 14 squared minus 2 times 9 times 14. Cosine of 62. You just do it in your calculator, right? Because you know that you can find cosine, what cosine 62 is. Then you have to multiply these all together and do it out. If you do that, you're going to get 158.69. 158.69. So x squared is that, which means that x is going to be the square root of 158.69, which is about 12.6. 12.6. Okay. So that's how you would use. So if you had a sine angle side, okay, side angle side is always going to be law. Okay, but you cannot use a law of sine. Okay, let's do the next one. We have 4, 7, and 9. 4, 7, and 9. And I know none of the angles, and they want me to find this angle right here. Okay, so I'm going to get 9 squared is equal to 4 squared plus 7 squared minus 2 times 4, 7 cosine, and we're going to call this x. It's going to be cosine x. Okay, and so you figure this out. So 81, 16, 49, minus, this is 56, cosine x. Move the 16 and the 49 over, divided by 56. If you do that, you get negative 16 over 56. Cosine x is equal to negative 15, did I say 15? 16 over 56. So go ahead and bring your calculators out. Go ahead and figure that out for me. Remember, you're looking to find the angle that gives you this value. Okay, so you would have to use the arc cosine function. Arc cosine of negative 16 over 56. By the way, this is by 8. I get 2 and 7, right? Negative 2 over 7. Yes, looks like you got an answer for me.
Like 107, 106.
Okay, 107, all right, anybody else? Anybody want to verify? Bill? 59, 107?
I'm still trying to.
Okay. No? Yes? No?
Yeah.
Yes? All right. Olin says it's yes. We're good to go. All right, flip the chain. Go to example number 4. Okay, example number 4. We have the ever famous Leaning Tower of Pisa. Why is the Leaning Tower of Pisa so famous? Besides that, it's leaning and not falling over. Besides that, didn't somebody do some pretty famous experiments there? No? No? Some guy named, doesn't ring a bell? Okay, whatever. Example number 4. Leaning Tower of Pisa is 56 meters tall. In 1999, the tower made a 100-degree angle with the ground. To stabilize the tower, an engineer considered attaching a cable from the top of the tower to a point that is 40 meters from the base. How long would the cable be, and what angle would it make with the ground? Okay, so this is the Pisa. This is 100 degrees, 40 meters from here to the ground, right? The tower itself is 56 meters, right? And I want to know this guy, and I also want to know, we'll call this A, this angle, okay? So let's work on this guy here first. X squared, right? X squared is 56 squared plus 40 squared plus, oh no, plus negative 2 times 40 times 56 cosine of 100 degrees. Right? And if I do this, I'm going to get 5513.9, 5513.9, which means that x is going to be the square root of this. With the square root, I'm going to get 74.3. So this guy here is going to be 74.3. Now realize, if I put this on the test, you guys have to actually do this. So you need to be able to do this, okay? All right. I'm going to assume you know how to do this. I'm just kind of whizzing by here because I mean, it's just a bunch of this, right? Okay. Doesn't mean that you guys don't have to know it. You guys have to know it, right? Okay, so 74 meters. Okay, so now I need to find A. How would I find A? I can put it back into here, right? To find this answer, now it's 56, right? Squared is equal to 74 squared plus this squared. I can do it that way. That would be the long and the hard way. But now I can actually use the law of sines, correct? Because I know this and this, I know this and this, well, I don't know this, right? So I have sine of A over 56, it's a 5. It's a funky looking 5, it's a 5. Okay, it's going to be equal to sine of 100 divided by 74.3. This is much easier, correct? Than using the cosine again on a different angle. Okay, so I would rather have you guys. Does the book do it this way? I hope. Yes, it does. Well, yeah, it does. Okay, yeah. So this is how you do. You usually law of sines at this point. Okay. All right. Okay, we're good. We're done. Oh, your homework is 1 through 37. Ooh, yikes. You can thank Mr. Dowell for that.